Okay, in this problem, I've got a wood column pinned at the top and bottom. So pin. Got an eccentric load of 10 kilonewtons. And I want to figure out, is it going to buckle? Is it going to yield? Okay. Gives me, E gives me sigma, or the yield stress on this. Okay, so the first thing I'm going to do is I'm going to calculate some of the values that I'll need. The first thing I'll probably need is the area. Okay. The area of this guy is just going to be 50 times 150. Oops, 0. 0.15. There we go. And from that, I get an area of 0.0075, and that'll be meters squared. Okay. Now I'm going to find the two I values, which is going to be 1/12 BH cubed. So the first one I'll have is 1/12 0.05, and then H is 150. And from that, I get 0.1234, and then 14. We'll just leave it at that. Meters to the fourth. So that would actually be the moment of inertia, I guess, about the x-axis. The moment of inertia about the y-axis is going to be, we flip those, and it's going to be 0.15 times 0.05 cubed. And from that guy, I get, let me do it this way instead, 1.56 times 10 to the negative 6 meters to the fourth. So, about the y-axis is the way it's going to buckle, right? That's the weak axis. Let me rewrite this so it's easier to tell the difference between these. This one is 14.06 times 10 to the minus 6. So you can see about the y-axis is the weak axis. About the x-axis is the strong axis. That means I want to find the radius of inertia about the strong axis so I can figure out the stress, the maximum stress that I see. So that's going to be, again, the square root of Ix over A. Okay. We've got Ix, A, throw that in there, and I get 0.0433 meters for the radius of gyration about the x-axis. So using those values, I should be able to figure out what I need to figure out. So I'll start with buckling. Okay. P critical for buckling is going to be pi squared E I over K L squared. Okay. Okay. So I get pi squared. E is given to me, I believe. Yep, 10 gigapascals. So 10 times 10 to the 9th for the wood. That was given in the problem statement. I, remember, it's going to buckle about the weak axis. So that's going to be the 1.56 times 10 to the minus 6 value for that guy. This guy is pinned. So K is 1. L is 3.5. Square that whole thing like that. And from that, I get that the critical load is 12.6 kilonewtons. Okay. So critical load is 12.6. Okay, that is greater than the 10 kilonewtons I was given. So we are okay. Give it a check mark. Okay. Okay, because it can handle up to 12.6. So if I only put 10 on it, we're A-okay. All right. So now I'm going to go to the sigma max using the secant formula. So this is the maximum stress, which, big ugly equation, P over A times 1 plus ECR squared. Again, this is about the stiffer axis. So we use the radius gyration about the stiffer axis. I think I have one too many. I don't need this. Okay. Secant of KL over 2R times the square root of P over EA. All right, so now it's just kind of a plug and chug. Okay, so let's see here. If I plug in, we'll plug in the maximum that I've got, okay, and see if it will yield with 12.6 kilonewtons in it. Okay, so we'll put it all the way to the max and say, okay, 12.6. Actually, let me not 12.6 because I want it in newtons. 12,600 divided by the area, 0.0075. Okay, times 1 plus the eccentricity of 0.15. C is going to be 75, half of that distance out to the edge, right? So that's going to be this, that's, from here to here, that's what C is. So that'll be 0.075 divided by R, which we calculated to be 0.0433 squared. Now this will be times the secant. Again, you want to remember to be in radians on this guy. Okay, and that's going to be, this is pinned, so it's going to be 1 times 3.5 divided by 2 times R, which is 0.0433, times the square root of, again, P, which is going to be 12,600, divided by 10 times 10 to the 9th. That's E. Again, that was given in the problem statement. And then area we calculated to be 0.0075. All right, so this is the maximum stress when I'm putting on the maximum load, the critical load, in fact, because I used the 12,600. So at that overload, I get 13.3 megapascals, which is less than the 15 megapascals that is my allowable load. So we're okay on that one too. And especially if we use the 10,000, because then that will actually be a lower stress than what I've got there. So even if I take it up to the buckling load, this thing can handle 12.6, not buckle, not fail in yield. Okay, if I only put 10 on it, then even more so, it will not do either. So we should be okay on this sort of a setup.